Hello, friends. So, this is a companion video of our event and session that we did today as part of the coffee initiative. And during the session, we discussed about software trust and integrity, overall agenda of software trust and integrity, and we picked up, malicious packages as a one of the attack vector or technique used by attackers to break software trust and integrity in your supply chain and CI/CD systems. And as part of the session, we used public repository, open source repository, which we created to help to do research on malicious packages available in research community, and that's called Maldeps, and it is available as a you can go to GitHub into repository J Chahan and Maldeps. And one of the first thing we will do, so in this session we will go through some of the uh, we'll explore Maldeps functionality and see how we can use it to do some research on malicious dependencies in your local environment without increasing the risk. uh, yeah, so let's get started. The first thing you need to do is clone the repository. Yeah, so go and happily clone it. And the repository actually has a set of malicious password protected malicious packages from various data feeds, including Datadog feed, and also from OSSF, and GitHub advisories. And we have picked up some packages from all of them and created this repository. And we have created a small environment using Dockers to play around and these repositories, these malicious packages, and also how we will see how we can even create one for our demo purpose. Yeah. So in order to, after cloning, I've just cloned the repo, and after cloning, uh, the first thing you need to do is set up a Docker environment if you have not already done it. And there is a link, go to the README. In the link, we have shown you some of the steps how to install a Docker environment, and also you need to also it's recommended that after installing Docker, you make it non the Docker you follow some instructions post Docker installation to make it not dependent on the root user. Yeah, so we assume that we have done it, and once it is done, and on Windows, you can always download you know Docker environment, desktop environment to make it easy. And yeah, so once it is done, I think the next step is to clone the repository as we have done, and also the next step will be to we will bring up the environment using running this command. So let's get started. Docker compose up -d, and this will actually build some of the container images at your local environment itself based on the source code. So it's going to take some time, but once it is done, we will show you what are the different repositories we have. So let's wait for some time. Yep, so after some time, as you can see that the build is successful. Now let's explore what we have got. So in Ja- so the setup right now has four containers running. One is PyPy Cloud, and it is a private repository built from open source project, which uh, which is very similar to PyPy, public repository, which you might be familiar, and it is used to publish packages and also to install. So we'll use it to publish our, custom packages, which may be malicious, of course. We don't want to publish them to public repositories, right? And it depends on Redis. So this is why this container is there. And then we have two containers. One is play, and second one is victim. So play contains, host the existing malicious packages, so that you can, explore them. And it also has a dev environment where you can go and create your own. Yeah. And victim is a victim machine which we can use to, install these packages and do, maybe test, if this malicious packages works or not, right? And this PyPy cloud actually is should be accessible even to your local host. Just go to your browser and go to this URL, and I think you will see a web app opened. It will ask, go to maybe login. The user and passwords are admin for your local environment. So you can, log in using admin, and you will see an empty list of repositories for now. Now we will see, one by one, how we can, explore. Of course, you can go to README file, and it will tell you the next step. The next step it tells you is to do exec to play. So we will go and do an exec to play. And once we do exec, we are in play container. Yeah. Now it has a few important directories. One is app. One is this directory which is under app, which is currently we are in, and malicious. And under samples we have various, I think 1400, around 1400 malicious packages from various data feeds. And then we also have a sample in others which we can use, malicious others, where we have LXML as a library, and this is not malicious right now, by the way. Just wanted to give a demo on. We just chose it for no reason. I mean, it could have been any other open source library. Yeah. And now, by the way, all these malicious packages in this are password protected, uh, for good reason. So we have also password unprotected packages in this temporary directory. Yeah. These are all zip files which are unprotected, password unprotected. And we will see, we can use it to, analyze some, packages, malicious packages and their internal structure. Now let's, do that. I think that's a very interesting thing. So we will do, let's analyze one of the package and see what it has. So I think one of the way we can do is to go to temp directory, make dir, analysis, create a directory called analysis. Now copy this, say one of the file like this. I think this will be, and then we will unzip it and see its source code. So in order to do that, run this command called unzip. Of course, we have to specify the location. I think, yeah, this is a location, and we will just do unzip it. Once unzip, it will be unzip into a directory called temp, this, and this is the package internal files. As you can see, the package contains various meta files such as package info. These, this is a structure which is very standard for a Python package. Then it also has a setup.py that is very interesting, because every library at least should have setup.py in order to specify how the package should be built. Yeah. And many of the malicious packages we will see here will install a hook into this file. Yeah. So let's, quickly jump and see what this file will contain. Let's open this in a Vim. By the way, do not run any of these files using Python, okay? Because these contain malicious code. Although we are running it in a container, so should be okay, but still do not run this. Now you can see that what this file contains. This is a typical structure of a malicious package that you have. If you notice that it is using, there is something called setup.tools, you know, uh, library package module inside Python, which consists of set of functions that we can use to create customize the package, such as find packages and so on, right? And we can see that this, I'm sure you definitely have noticed something fishy here, and one of them, that fishy thing is happening here itself. So can you see that what it is happening? So the malicious package actually is importing a internal function from OS system library. Why internal function? Maybe it is trying to bypass usual signatures, which looks for just OS and system. Okay. Then it is creating a temporary file. Can you see that it is using internal functions rather than the function themselves? Yeah. So that the code potentially bypass signatures, right? So it is creating a temporary file, writing a file, and then starting it, executing it. Yeah, and this happens whenever package get installed. That's it. I think this is what it does, and this is a base. This is how the package can get malicious. Of course, the you know advanced malicious packages add some bit of obfuscation. As we can see, we can analyze other packages too. Now, if you want to see, what all techniques being used to for all of these packages, there is a folder. I think there is a folder. There is a file inside this directory, and this is called. Let me see if there is a file or not. No. Okay. So there is a tool, we have packaged from Datadog called guard dog. Okay, and this guard dog you can use the guard dog even to analyze what technique a package is using without even you know uh, unzipping the package, and this is how you can run it. You can run on multiple files too, but let's pick up one of the file, say this file, and let's see whether it can detect something fishy, something risky. Yeah, so if you run, I think, oh yeah, we need to give specify commands. We need to know whether it's a PyPy scan, and that's it. And it will show you that if it has found something. So in this case, it has found one potentially malicious indicators. So this tool actually gives indicators rather than calling it malicious. It tells you what indicators it has found. By the way, it is found indicators for even legitimate libraries. So just having indicator does not mean it is malicious. It need to be manually vetted in order to conclude that it is a malicious library. Yeah. So as you can see that it is using a package, it is using a command, inside it, setup.py, okay, and at line number 9, where it is using PowerShell and some base64 encoded data command to run, and this makes it malicious, and which looks malicious to me too, you know. Um, and you can run this same thing on other packages to find out the other malicious content. By the way, we have summarized key techniques visually in our session. So if you want to see a summary of all the techniques that we have used so far, that these packages uses, malicious packages uses, then you can always go to session and get a summary from there. Yeah. So I also wanted to show that this is not that this tool can also be used to find risky indicators in your existing code. Okay, so in order to do that, just go app, Then go to yeah. So we have non-malicious. We have our own non-malicious library. I think we will just go and scan it. By the way, this tool has some issues, while scanning. So what you need to do is just like it gives an error. So I'll just give a top level directory and then probably it works. Yeah. So you can see that this tool actually highlights some of the things from, yeah, some of the things, right, in this library. Yeah. So there is a virtual environment called .vnv where it has found something. I think it is also finding in a virtual environment we have created, but I think the main code which is potentially indicated for this library is this. So ignoring this .vnv because we created it ourselves, I think this is where this is a place where it is telling that this LXML is potentially vulnerable, but actually it is not. We know that LXML is not vulnerable, right? So we will use this function. Actually, we will in a next session. I think we will use LXML to convert it into a malicious library. We will use its own feature to convert it into a malicious library, and we will publish it. But for now, I just wanted to highlight that it, this tool can also give indicator for normal libraries too. So does not mean that it is malicious, but it's a good indicator. It's a good check that we should use. We can use to see if there is no maliciousness, being committed. Yeah. Okay. So this is how you can, go and package. You can see a package. Apart from that, now we will also see how we can, convert a library into a malicious library, and we will use a typo squatting attack, similar to typo squatting attack. Okay, so in order to do that, we'll go back to our LXML, you know, app, malicious, others. Now LXML, now there are actually tools to that can generate all the name variations of typo squatting. There is a tool called DNS Twist. I think you can there is online version, web version available, but you can also download it. I'm sure it is not there here, but we don't have to use it, I think, in this case. But if you want to generate any other variation of a name, you can use DNS Twist, and there are other typo squatting tools available. You can find it on GitHub that can, given a name, it can generate it a lot of variations, and you can choose one of them. But then we will do a simpler thing. We will, choose a different name. So let's do one thing. Let's first of all copy LXML into -r into another library called LXMI. Yeah. Okay. Let's do that. Yeah. We did that. Now let's go to LXMI, which is our typo squatting quoted name of LXML. Now, as we seen in the session that for Python attackers, target setter.py or similar thing. I think in this case, setter.info and setter.py are similar. Setter.info is a companion library, companion file along with setter.py. And if we saw during the last command that setter.info has at line number 367 has something which executes a code, right? So let's check it out. What is this? 364, this file and 364. So 364. Yeah, so we can see that I think somehow the line got, yeah, so at this line, we can see that it has a function to run command. It has a utility function which it uses internally to run command, and then it uses this function, I think, it's for its own sake, like it uses this function for getting the library version, and get flags, get Xcode is whenever it runs on Mac, I think Xcode, right? So probably what we can do is the first step, I think we change the name. Second step is to embed a malicious command. Okay, so what we are going to do, we are going to run, you know, add a demo command. Okay, I think we can use a netcat. In our case, we can use play. So if you know, netcat can be used to create a reverse TCP tunnel, right? And one of the way that it can create is to create netcat attacker IP, some port number. So we choose say a port number this minus E and then bash. Okay. So whenever it runs, it actually, you can actually also do one more thing. You can do no hub and then also run it at the background so that whenever it runs, it spawn a shell, okay, at the background and it connect to the remote end to get a command. Yeah. So this is a small malicious thing we have inserted. Now next step is to also change the library name. So we will go to generally library names are specified in setup.py and it is you will find it at the end, I think. So this is a structure of a yeah. This is the function that every library will call. Setup. Okay, to where it specify the name, version, and everything. So we will just change the name here rather than calling LXML. We will call LXMI so that we can build it and publish it. Now next step is you can call the command called cwheel. So that is one command you can do to build it. Okay. Second command I think is you can use is to yeah. So we will use this command called make wheel, and what it is going to do is going to build it. As you can see that it has built a file, you know, and generally when it builds a file, it keep it here. So this is a previous file actually. We had just copied the directory, right? So it got copied. So this is a new file which is being created, LXMI. And now how will you publish it to a repository? Okay, so for that, we will use a command called twin. Okay, now how will you get this command? I think you will get it from the README file. Okay, so there is a README file. Let's see if there is a command twin. Yeah, there is a command called twin. Twin basically is a tool that uh, Python guys use to publish packages to the remote repository. So we're going to use this twin. And what it does, I'll show you, you can simply use this, right? Twin upload repository URL, and then also specify the file itself. Okay, and then uh, typo, not squatting, but just type. It will ask password, so admin. Yeah, I think there is some issue here. Possibly it is not set up properly. Let me get back. Uploading error while upload retry with verbose for more details unauthorized. Looks like the oh something issue 8080 simple. Let me get back on this just one moment. Let me troubleshoot and come back. Yeah, I think it seems that before using this private repository, you have to go and register an admin and just go and register an admin. I think if you browse this, it will ask you to register an admin with username and password. Just choose admin for now as username and password because we have used it at a couple of places. Yeah. Once I did that, I think now it will be possible to upload. Yeah, so you can see that the library is being uploaded. If you go back to this repository, you'll be able to see the library is being, yeah, okay, sorry, I have to, yeah, you can see that library is being uploaded. Yeah, and it's okay. Now let's see, at the attacker end, what happens at the victim end. So I'll log into victim now, and we will try to install the library victim, exec victim bash. Okay, so generally victim can just do pip install lxm. Suppose I go to Google and I found out this is a library, I want to install it, and this is what happens. Once I install it, this library being installed at my local, now I can go and use it in my any other software. Okay, so let's see if I can, I'll write, uh, Python. Okay, okay, so after we installed, we can see that the package got installed, lxmi, yeah, something like this. Yeah, okay, so you can, build and publish malicious packages, and then you can use it. The next thing you can use it is, you can use it, build a like something like this, import lxmi, and then you can write a small program and run it. Yeah, yeah, so this concludes, our demo of the environment that we have built. And if you have any questions, please feel free to write me back. I'll happy to answer, or even, create a ticket on the Maldeps. Okay. Yeah. Thanks. Thanks a lot. Enjoy. Bye.